Hello guys, my name is Andres Sava and today we'll be discussing the magnetic fluid. The materials that we will be using today, it's vegetable oil, magnets, and Epson uh, ink, printer ink. How do magnets work? All magnets have north and south poles. Opposite poles are attracted to each other while the same poles repel each other. When you wrap a piece of iron along a magnet, the north-sinking poles of the atoms in the iron line up in the same direction. The force generated by the aligned atom creates a magnetic field. Ferrofluid. Ferrofluid is a colloidal suspension of small magnetic particles in a fluid. In a suspension, solid particles are dispersed. The viscosity of the fluid, the tiny size of the particles, and the particles' constant motion keep the solids from settling out. The magnetic particles in ferrofluid are around 10 nanometers in size. A nanometer is a billionth of a meter. Particles in this size are known as colloids. The magnetic particles in ferrofluids are usually iron oxide, magnetite, synthesized in solution and precipitated as nanoparticles. Iron salts, iron 3 chloride and iron 3 chloride, iron 2 and iron 3 chloride, are mixed in a basic solution, tiny particles of iron oxide precipitate from the solution. The iron oxide particles are coated with a surfactant to keep them from sticking to each other. The particles are dispersed in a water-based or oil-based fluid. Iron oxide is the same compound as magnetic and naturally magnetic mineral found in many igneous and metamorphic rocks. How can it act like a liquid and a solid? Ferrofluid is a super paramagnetic, a property that is found only at the nanoscale. At the microscale, ferromagnetic materials like refrigerator magnets are permanently magnetic, but when ferromagnetic materials are nanometer sized, they become paramagnetic, which means that they behave like magnets only in the presence of a magnetic field. When there is no magnet nearby, the magnetic particles in ferrofluid act like normal metal particles in suspension. But in the presence of a magnet, the particles are temporarily magnetized. They form structures within the fluid, causing the ferrofluid to act more like a solid. When the magnetic field is removed, the particles are demagnetized and ferrofluid acts like liquid again. Ferrofluid is a unique material that acts like a magnetic solid and like a liquid. Ferrofluid is made of magnetite, as we mentioned earlier. Ferrofluid is made of tiny nanometer-sized particles of coated magnetite suspended in liquid. When there is no magnet around, ferrofluid acts like a liquid. The magnetized particles move freely in the fluid, but when there is a magnet nearby, the particles are temporarily magnetized. They form structures within the fluid, causing the ferrofluid to act more like a solid. When the magnet is removed, the particles are demagnetized and ferrofluid acts like a liquid again. Right. This is the experiment. Here I added the uh, printer ink of 50 milliliters. Then I added 2 tablespoons of vegetable oil. As we said earlier, the particles are dispersed in a water or oil-based liquid. I mixed it really well. I add a little more oil, and then I transfer the liquid to a smaller container in order for me to be easier to see the reaction. Okay. I use 2 magnet spheres, regular magnets, and I put it closer to the glass or the container. Just trying to move it around, nothing happened. As you can see from here, I have a better angle that I'm gonna try to show you in a second. So I have the magnet on the bottom. I still have the magnet on the bottom. There's no spikes or anything happening to the liquid. So the experiment, we can say that it wasn't successful. Here's how it should be the image. So we see the magnet on the bottom, we see a surface in between the magnet, and on top it's a ferrofluid liquid. So it should be spikes coming out of the liquid. Uh, as we saw on the experiment I performed, the experiment was not successful. That maybe is because the magnets that I used, maybe they were not too strong or strong enough to create strongly magnetic field. Another reason that might happen is because the ink that I use, maybe it wasn't high percentage ferrofluid. Maybe it was something else. I use as the experiment instructed ink, printer ink to be more precise. In the future, I will make sure that I use more or a higher percentage ferrofluid ink and better um, magnets in order for the experiment to be successful.